About 1 billion years from now, the sun will become a red giant and will inevitably destroy all life on Earth. That is why scientists all over the world are already searching for a new home. The explorer within us has allowed humanity to conquer the harshest corners of our planet. We have descended to the bottom of the Mariana Trench, carved paths where none existed before, discovered new biological species, and created safe habitats in the middle of wild jungles. In the early 20th century, adventurers armed with only basic equipment explored the kingdom of eternal ice and silence, Antarctica. Surviving in that frozen wasteland required extraordinary creativity and adaptation. Today, our ambitions go far beyond the most remote places on Earth. Looking up at the night sky, we ask ourselves, is there another place we could call home? For a long time, we believed Mars would be the next stop in humanity's journey through space, until one day we discovered Titan, a mysterious celestial body near Saturn. What does it take to build a colony millions of miles away from Earth? Why is colonizing Mars a bad idea? And is our technological progress sufficient to send human colonists on a one-way journey to Titan? Let's try to figure it out. On Earth, there are several key factors that make life possible. Oxygen that we can breathe, a comfortable temperature, water, and protection from all kinds of radiation. Finding the same conditions elsewhere in space is like winning the lottery. Take Mars, for example. Recent rover studies show that there was once water on its surface, the climate was warm, and potentially life existed. But all of that is long gone. And today, the planet is nothing like it once was. Now it is a lifeless desert, where the average temperature chills to the bone with extremely high levels of radiation. But let's imagine that we decided to build a colony on Mars. To do that, we would need to send a team of colonists in a rocket. And after about 7 months, they would become the first humans to step onto the surface of the red planet. The first task would be to build a safe habitat capable of maintaining the proper oxygen level in the air and a comfortable temperature. At the same time, the area must be large enough for people to live and to support the necessary equipment. Scientists are already searching for the safest location, rich in natural resources. It is there that the first megastructures will be built, a chain of large domes forming the foundation of a future settlement. All of this is needed to protect people from cosmic radiation and dust storms. Now the colony no longer faces threats from the outside, but it still depends on constant supplies of water, oxygen, and energy from Earth. Life in the colony is not easy. Biologists spend most of their day trying to find ways to improve plant growth because even slight changes in temperature, pressure, gravity, or humidity can destroy the entire harvest in a moment. The colony will be completely dependent on this. One of the key sources of energy will be solar panels. But unfortunately, Mars experiences dust storms that can last for months. In addition, Mars has a very thin atmosphere, about 100 times thinner than Earth's, and there is no magnetic shield, meaning solar radiation is a constant threat to the colonists. Perhaps humanity could create an artificial atmosphere on Mars with comfortable levels of radiation and temperature. There is already an idea that if we detonate several nuclear bombs at its poles, the temperature on the surface would rise sharply, and along with it, an atmosphere rich in nitrogen and oxygen would appear. But in reality, this would not work. And here is why. Water vapor and carbon dioxide are important greenhouse gases on Earth, while Mars has 99% less carbon dioxide. Moreover, most of the carbon dioxide on the red planet is trapped in non-atmospheric reservoirs, such as polar ice and minerals. But even if we could access those reservoirs, there would still not be enough carbon dioxide to significantly affect the planet's atmosphere. In addition, we should not forget about the radiation released by nuclear warheads, which would make Mars even less suitable for life, at least in regions closer to its poles. Overall, the only thing that makes Mars attractive is its relatively short distance from Earth. But what if there is a world that is far better suited for our cosmic ambitions? Titan is a cold, icy moon that orbits Saturn and is even farther from Earth than Mars. We have already built one space colony, the International Space Station. It is only 400 kilometers away from Earth, and its crew requires constant resupply. The same would be true for a colony on Mars. But on the surface of Titan, there is already an abundance of resources. The Cassini spacecraft took almost 7 years to reach Saturn. Fortunately, scientists are confident that within 50 years, our technological progress will allow a rocket to travel from Earth to Saturn in just 2 years. One of the main advantages of Titan over Mars is its atmosphere, which is 50% denser than Earth's, making it relatively comfortable for humans. In addition, the dense atmosphere provides protection from meteorites and radiation. It also solves the problem of transportation, since without roads and infrastructure, the only option is air travel. And in Titan's conditions, transportation would be much easier. Despite all the advantages, there are problems in Titan's atmosphere. The first is a mixture of hydrocarbons with oxygen, which together create an explosive combination. And the second is thermal insulation, around minus 180 degrees Celsius. Also, there are no strong winds on Titan, so while insulation is a problem, it is not a major one. Humans already have the technology to deal with it. Homes on Titan would consist of large domes made of aerogel. No heavy armor is needed, which means there is no need to carry extra weight. There is also no need to go underground to protect against cosmic radiation and solar flares. Heavy spacesuits are not required. A simple oxygen tank and insulated clothing would be enough. Moreover, a breach in a compartment would not lead to instant death for everyone inside, as it would on Mars. It would be entirely possible to put on an oxygen mask and move to another section. We should also not forget about landing on the surface as one of the most difficult stages. For Titan, this is solved with parachutes. In its dense atmosphere, they are highly effective. While on Mars, they are almost useless and can only be used for initial deceleration. The next challenge for colonists would be resources. Both Mars and Titan have sufficient water. As for Titan, little is known because it has not been studied extensively. It is believed that there are underground lakes of methane. Nothing is known about metals on Titan, unlike Mars. However, when considering resources, it makes more sense to look not at the moon itself, but at the entire Saturn system. And here, Titan becomes far richer than Mars. Metals exist on other moons of Saturn. But more importantly, Saturn itself is a source of helium-3, which is an excellent fuel for fusion reactors. This means that the minimum requirement for colonizing Titan is the development of advanced fusion energy, since there is almost no solar energy available there. On the other hand, it is also unreliable on Mars, where dust storms can last for months. Gases in the Saturn system are so abundant that they could become an excellent export resource. Many already predict that there is clear economic benefit in mining helium-3 on Saturn, since unlike Jupiter, Saturn has lower gravity and radiation. In addition, Titan has a massive underground ocean, and it is there that the first complex extraterrestrial life in history could be hiding, possibly resembling the organisms that live at the bottom of Earth's oceans. Once the colony on Titan solves the oxygen issue, it will begin to grow plants. Titan's atmosphere, like Earth's, is rich in nitrogen, which is a key chemical element acting as a fertilizer for crops. It takes light about 80 minutes to travel from the sun to Titan, which means the moon receives 100 times less sunlight than Earth. Titan orbits Saturn, not the sun, so the colony will need to find a way to create an artificial source of sunlight. The colony would most likely be built on the side of Titan facing Saturn, where reflected light from Saturn could provide a faint level of illumination throughout the day, except during periods when Titan passes into Saturn's shadow. A day on Titan lasts 16 Earth days, so for a couple of weeks, the lighting would be slightly enhanced by the sun, and the next couple of weeks would be darker. A year on Titan is equal to 29 Earth years, meaning each of the 4 seasons lasts about 7 Earth years. We still do not know much about Titan, but we do know that if we reach it, we could live there. The process of colonization is not as simple as it may seem at first glance. In this episode, we have touched on only some of the challenges. Whether it is Mars or Titan, humanity is only beginning to take its first steps into space, and that means everything interesting is still ahead.